First, thank you for joining this meeting. That will be on the topic test-driven development for server-side JavaScript. Before we start, I have a small question to you. How many of you are using test-driven development in their daily work or have used test-driven development? Raise your hands, please. Great. There are some people, so we have some experience here at the room. That's great because in this session you will get some new ideas on how test-driven development can be applied to server-side JavaScript. You will see how to debug, how to develop server-side JavaScript without needing a server, without need to deploy this on the server. And because while we are developing, we have some pressure from the management. They want to release faster and faster the features for their products, but without compromising the quality. Test-driven development is the thing that will shorten your feature release cycles without compromising the quality of your code. The agenda. First, why one should use test-driven development? What is the experience that we have? Next, TDD4JS framework. This is an open source framework which facilitates test-driven development for server-side JavaScript, and we have created it to be able to do test-driven development. Next, the demo and the conclusion. To be on the same page, I saw there is some experience in this room with test-driven development, but to be all on the same page, let me remind you what test-driven development is about. This could be summarized in an acronym word called FIRST. F is for fast. This means tests developed with test-driven development must be fast. They must be executed in milliseconds. I is for independent. Tests must not depend on the execution of each other. R, repeatable. If we have 10 failing tests, if I run it 10 times, they must fail 10 times. And not sometimes fail, sometimes pass. This is the contrast with the integration tests. S is for self-checking. Tests must be self-checked. There must be no human that should go and see and say, this test passed, this test doesn't pass. And finally, T. This means that these tests must be written in a timely manner, which means, first, we write test which fails. Then we write the productive code, small piece of productive code to satisfy the test, to become green. Then we can refactor, we can remove the redundancy in our productive code, we could apply clean code, etc., what we want, and then we turn back to the cycle, the next test, etc. What is my own experience with test-driven development is the following. A year ago, I had the pleasure to join a project which was a large-scale server-side JavaScript project at SAP. It was about HANA. The project was running on SAP HANA. And what we had there is in the beginning of the project, it was fine. There were some existing features, but additional features should be added to this project. And in the beginning, there were only integration tests. And that was fine, because they were running for about 10, 20 minutes. But month after month after month, we have added new features to this product, and it was not acceptable for us to wait hours for the integration test suite to pass, just to see that we have missed a small bug in our new feature or in our bug fix. Because what happens, we submit our bug fix or new feature, we run the integration tests, we wait for 3 hours or more just to see that one of the tests is failing and we have small bug, we have to fix it again, submit the code and rerun. This is not acceptable because it slows us. Test-driven development allowed our team to work in parallel because we had a bottleneck, and it was the server. When 2 team members had to work on new features, or one is bug fixing, one is creating a new feature, we had to wait for our server because our productive code was there, and our 2 team members most of the time have conflicts on working on their tasks because they depend on the productive code which is deployed on the server. And if one of the team members changes this code, the other cannot do his job. Test-driven development helps us to develop our productive code locally and debug it locally without deploying it. Next, improvement of the code design. This is something that is written in the books, but this is something that we observed into our project. And I mentioned adding features faster and bug fixing with greater confidence, because when one bug fixes something, he runs the test suite, it passes for a minute, for example, if there are many, many tests, and the developer gets his feedback immediately. The framework. When we wanted to apply test-driven development for server-side JavaScript, because this was our project for, we needed to have continuous integration for our JavaScript tests. We need to have isolation. We need to have nice reports. This is something which we didn't found with the existing frameworks, but we do found frameworks that facilitates parts of the things that we want to achieve. So we combine them. First, QUnit. This framework is open source and it allows us to write test-driven development for JavaScript. Next, Rhino. Rhino is a JavaScript engine that it's an engine which allows us to run JavaScript in Java. And finally, JUnit. JUnit have a quite nice integration with Maven. So when you run your Maven, it runs all your JUnits and you get immediate report for the status of your product. What are the details in our framework? First, we have 2 scenarios for it. 1, continuous integration. When we run Maven, we want all our QUnits from our product to be executed. They must be gathered and executed. Maven runs our JUnit. Our JUnit gathers all the QUnits which are for our framework, loads their dependencies, and sends them for execution in Rhino. Rhino runs these scripts using QUnit. QUnit produces the result and sends them back to JUnit. JUnit produces nice, surefire reports which are readable by any continuous integration system like Jenkins. Next, local development. Here is the part where we can locally develop and debug our server-side JavaScript. Again, without running a server, without deploying on a server. What we do here, we open our browser, we drag and drop the HTML file with our tests in it, and we just refresh the browser. Next to the browser, we open our IDE, and we develop our productive code. When we develop productive code, we just refresh the browser to see the status of our test. Having server-side JavaScript, most probably you'll want to test some things. Let me tell you our scenario here. We have a Node.js service which is connecting to a database. In the database we have users. Node.js service gets these users from the database, make some calculation on the data of these users, and send the response back to our client. Let me show you what can be tested here. First, our Node.js service gets an input, the postcode, but in the database we have users with their cities. So we need to construct a query which as parameter has a city, but as input we have a postcode. So we have to make a mapping here. We have to map postcode to city. This logic here can be test-driven tested. Next, data transformation. When we execute our query, we get a result from the database. But to this result, we need to add some additional fields before we send it back to the client. For example, in our use case, from the database, we get the salary for the user, but for the client, we need one additional field, the credit limit, which is calculated based on the salary. What we do is to make this calculation in our Node.js service, put the credit limit into the data object and send it back to the client. This can be test-driven tested. And finally, the service response. This is what our service sends to the client. Service receives some input parameters, and based on whether they are valid or invalid, we create different responses and send them to the user. This also can be test-driven tested. And now, it's time for the demo. Let's see how we could develop locally a new feature for our product without deploying. Let's see how we run Maven and how it executes our tests for our framework. And let's see finally the reports in the framework. First, I will start my Node.js service, which is starting a server on my local host. Next, I'll open my browser, connect to this service. Because my service wants postcode, it gives me invalid input. So I'm accepting to run it with postcode 1000, which is city Sofia. And it gives me the output. This is the output from the database, but modified with new fields, which are inserted by our Node.js service. You may see here the city. We have the postcode as input, but we have the city from the database. This is, if you remember, our logic for query construction. Next, we have salary in the database, but here in the client, we have credit limit. This is additional field that we have calculated and added. before we sending the object back to the client. This is what is our data transformation layer, and this is what we have tested using our framework. Let me show you how my project looks like. For the simplicity of the demo, I have added everything in one single project. In main.js, I have my productive code. This is server.js. In test.js, I have my tests for the different layers that I explained: data transformation, query construction, and service response tests. The framework, TDD4JS framework, is in test Java. You may see here that it's a, let's say, simple JUnit test called QUnit test. It gathers all QUnits from our project and executes them when one runs Maven. To be able to test our Node.js service without deploying, we need to isolate our code. You may see here some require function. This require function loads additional modules, but we don't want them for our test-driven development, because we need to test only our logic. That's why I have created quite simple mock. You may see it. This is my require function. Based on the module name, I return very, very simple mocks. Only the things that I need to my tests. I have created my mock once, and I'm reusing it through all my tests. And I have created different tests for the different layers. Let me show you the different layers in our productive code. First, the data transformation. You may see here, in our Node.js service, we receive the salary from the database. And based on some logic, we add additional field to the data object, which is called credit limit. And we send this data object back to the client. This is what we can test, drive, and we can apply test-driven development for this test. Next layer, query construction. We have postcode as input to our service, but you may see in the select statement, in the where clause, we need city. And here, we need to have a mapping between our input parameters for our service and the things that we will send to the database. This query construction layer can be test-driven tested. Finally, our service function, the service response. We have the request and response to this function. In the request, we have some input parameters, for example, the postcode. If the postcode is undefined, we return a simple error, HTTP 400, with some message to the client. This code, the service response, can also be test-driven tested. After showing you the productive code, let us see how a test for our framework looks like. It's a simple HTML file which, with script tags of HTML, includes the additional dependencies to the productive code that we want to test. That's fine, but we have additional metadata tags like these ones. Rhino load. This is needed for our framework to gather the additional dependencies for our test and to execute them. You may see our mock is here as additional dependencies. Server.js is also additional dependency. This is our productive code. And finally, the Rhino test suite metadata tags, the script where we have our tests, our QUnit test. There is nothing special here. This module, setup, teardown, this is QUnit. And finally, our test. In this case, the test is for the credit limit. Let us run the Maven. Will the build be fast? There is no starting server, so we have built our project in less than 3 seconds. Let me show you the test section. You may see here, execution of QUnit test. This is the entry point of our TDD4JS framework. QUnit test gathers all tests which we have written in our product. You may see data transformation HTML. This is one of our tests. It is gathered and executed. And you may see it's pretty fast for 30 milliseconds. Next, query construction test, 9 milliseconds. No deploy, just local execution and test of our logic. We see here quite fast execution of our test suites. But can we add a new feature for our product in fast and reliable? Let's see. Let's say we want additional field to be sent to our client, and say this field to be credit deadline. Let's say we want credit deadline for City Sofia to be 10 days. This is our new feature which we will have in our Node.js service. This can be done in data transformation layer, where we get something like city from the database, and we create a new field like credit deadline for our client. That's why I'm opening my data transformation test. As a template, I'll use the existing test for the credit limit. I'll copy and paste it. Change the name of the test, like credit deadline for City Sofia is 10 days. You may see create data object function. This is my productive function. As input, it gets the result from the query execution. And the result here for this test is the city. So I expect city to come from the database. And because my test is for City Sofia, I expect database to be returned City Sofia. What I need next for my new feature? First, I need in my data object to have the field city. And I need this city to be City Sofia, because this is the test that I'm writing. That's fine. Next, my new feature, credit deadline. Credit deadline, I expect it to be 10 days, because it is City Sofia. Finally, I change the message if the test fails to receive meaningful message. Next, let's run our test. Simply drag and drop in your browser, and you see the test is failing. Great, we are applying test-driven development. This is the first place. We have the test and it's failing. Our first assertion here is fine, because we already have the productive functionality that transfers the city to the client. But our next assertion, our new feature, the credit deadline, is failing because we don't have the productive implementation yet in our service. You may see we expect 10 days, but we have undefined. Let's go and do our productive implementation. Step 2 in our test-driven development. I'm opening the server.js, my productive code, going to data transformation layer, where my credit limit is, and I'll add my new feature for credit deadline here. Based on the city which I get from the database, I'll create the credit deadline. And here, if I have City Sofia from the database, I'll return 10 days for the deadline. If it's not City Sofia, I don't know yet. I'll just pass undefined. We have our test, we have our predictive implementation. Let's rerun the test. It's passing, that's great. We have our feature. Let's see whether our feature is not breaking any existing features in our product. I'll just rerun the Maven and go to the test section. You may see my new test is here, and it's running fast. And it is testing server-side JavaScript. Next, I could submit in my source control system, run my integration tests, and so on. But here, I'll deploy my service, which is, in my case, copy and paste a file for the demo, and rerun the server. I want to see whether my new field in my server is sent to the client. I'll go, connect to my service, and here, it's City Sofia, and we have our new predictive feature for the credit deadline, developed locally. Let's see other cities. For example, Varna. We don't have there this credit deadline because we didn't implement it. Let me show you now how one could see the reports from the execution of this Maven. Maven execution runs QUnit, which is the entry point of our TDD4JS framework. It creates this QUnit test report, which from Eclipse, if you double click on this XML file, you get a nice report in JUnit view of Eclipse. You see the report here. We have all our tests which we have written for TDD4JS framework. They're in HTML files. You can see also the path to these HTML files. And if something brokens here, just drag and drop your HTML file in your favorite browser and debug it. That's it. You don't have to start server. You don't have to start database server. You don't have to deploy. Just drag and drop and bug fix. As a conclusion, test-driven development is something that I personally believe, and my colleagues at SAP also believe in it. Because it keeps our code in great shape, and it shortens the release cycles of our features. It saves us time. We don't have to deploy. We don't have to wait for a bottleneck of our server. We just develop locally in parallel. And when we submit our code in the source control system, we're pretty sure that our new feature or bug fix is working without breaking any existing functionality. And we're 99% sure that all integration tests will pass. In the demo, you saw that test-driven development for server-side JavaScript is successfully applied. This is not only the demo. This is what we've really done at SAP. Finally, I will encourage you to try the open source framework which we have created. It will make you to make test-driven development more easily for your server-side JavaScript. And that's it for me. Now it's time for questions and answers. please. Are you ready to apply test-driven development now? Do you feel more comfortable with it? Okay, I see no questions now. However, if you get some question, you may go and see me and ask me. It will be a pleasure for me to answer you. And I want to remind you that there is a closing word at main hall, so don't leave now, just go to the main hall and let's close this conference. And of course, there's party at the end. Thank you for watching the session.